So in this video, we're going to learn another method we can use to solve equations that are exponentials, where a variable is in the exponent. I have a few rules written down over here, but I'm going to go ahead and just start the problem and then kind of explain these as they come up. On this first example here, I can obviously start this problem by subtracting 3. That much is pretty clear. After I do that, though, I have 5 to the x power is equal to 7. And I need to solve that equation for x, which means getting x all by itself. It's really tough to get a variable by itself when it's in the exponent here. And in the last video, we learned that if the number here, the bases are the same, you can just set your exponents equal to each other, and you can just solve it, and it works out pretty easily. Unfortunately, though, if you have a 5 and a 7 here, there's not a clear, easy way to make them the same base. I can't really rewrite my 7 as 5 to some power. Not anything that's going to be clean anyway. So the method that we learned in the last video is kind of out of luck on this problem right here. We can't just make the bases the same. So we need a second method, and it involves logarithms, actually. One of the properties that I taught you in the first video of this segment is going to come up big in this example here today. So what I'm going to do on this problem here is actually go ahead and take the log of both sides. I'm going to take a log on this side, and I'm going to take a log on this side as well. Just like you would add a number to both sides of a problem, you can subtract a number, you can take the log of both sides of the problem. The reason this is actually going to be a good thing, and why we would ever want to do this in the first place, one of the properties I showed you guys in that first video told us that if we have an exponent inside a log right here, we're allowed to take that exponent, drag it out front, and multiply. So I'm going to take this x, my exponent, and I'm going to move it down out front. So what's actually going to happen is this is going to turn into x times log of 5. I took my exponent and I dragged it out front there. This side is still just going to say log of 7. So I have that problem now, and this is a lot better because x isn't in the exponent anymore. It's out front. All I have to do to solve is just divide by that log of 5 right there. So I'm just going to take both sides of my problem. I'm going to divide by log of 5. These will cancel, so I'm just going to get x equals this over here. And I can just type that in the calculator and see what it equals. So I'm going to do that real fast. When you type this in the calculator, just make sure that you do close the parentheses. If you don't close them, it might misread it for you. But if you round the answer here, it looks like that's going to equal x equals 1.21. So after we took the log of both sides, we dragged down our exponent, we divided, and we were able to solve that equation. We have one more example in this video, and for this problem here, I'm going to start it off the same way. I have a thing by itself. I can't make these the same base like in the last video. So I'm going to go ahead and take the log of both sides here. After I take the log of both sides, I'm going to drag down that exponent out front and multiply by that. So it's going to say x minus 4 times log of 9. I took my exponent and I put it in the front of the problem there. After I do that, my second side over here, my right side, is just going to stay the same. It's going to be log of 160. So in order to solve this equation, I have this log 9 over here that I'm multiplying by. I'm just going to divide both sides by log 9. So I'm just going to divide by log 9 over here as well. When I do that, these will cancel. This side will just say x minus 4. And again, I'll take my calculator to divide out that part right there. So if I divide log 160 divided by log 9, again, I'm remembering to close my parentheses here. That equals, if I round it, it'd be 2.31. So this side over here is a 2.31. And then I simply add 4 to get my answer here. So I'm going to end up with x equals 6.31. So anytime you want to solve an exponential equation where your variable is in the exponents, you can take the log of both sides and use the property to bring it out front and multiply. It's all from there.